Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told that two parallel wires each has the same length and same mass per unit length, but different tensions on each wire. If we generate transverse waves simultaneously, one at the left end of wire A and one at the right end of wire B, we want to know the time that elapses before the pulses pass each other. Now, we know that each pulse will travel a distance that is given by v times t, the speed times time. And t is the travel time up to the point that they will pass each other. Now, the sum of the distances traveled by each pulse has to equal to 50 meters, which is the length of the wire. Now, this is since each pulse starts out at opposite ends of the wire. So if we use VA and VB to denote the speeds on wire A and wire B respectively, we have the following expression. We have VA times T, the distance traveled by the pulse on wire A, plus VB times T, the distance traveled by the pulse on wire B, must equal to 50 meters. So let's solve for time from this equation. We get the time for the wire to pass each other, for the pulses to pass each other rather, to be 50 meters divided by VA plus VB. But we don't have the speeds of the pulses, but we have an expression for the speed of a sound wave on a wire. So this becomes 50 meters divided by the square root of the tension on wire A, FA, divided by the mass per unit length on wire A, M over L, plus we can replace VB with the square root of the tension on wire B, FB, divided by its mass per unit length, M over L. Remember, M over L is the same for both wires. They both have the same mass per unit length. Now, these values are all known, so we can calculate this time. So this is 50 meters divided by the square root of the tension for wire A, which is 6 times 10 to the 2 newtons, divided by its mass per unit length of 0.02 kg per meter, plus the values for wire B. Its tension is 3 times 10 to the 2 newtons, divided by its mass per unit length is the same, 0.02 kilograms per meter. And so if we calculate this, we get the time it takes for the two pulses to pass each other to be 0.17 seconds.